Okay, so there's that. Okay, all right, so we have stuff. We have stuff from your test that we can go over. We have stuff from homework that we can go over, and we have new material to go over. So I gave you guys back your homework. Is there anything that you guys, any particular questions that you all know you want me to go over? From the work you guys did last week, or anything from your homework? Anything there that you know didn't make sense and you want to go over? Hey, Olivia. Here you go. This is you. I have a collection for you.
Question 86.
Which lesson?
Lesson 31 and question 1 in lesson 33.
31:6, 33:1. Okay.
Lesson 29, question 22.
29, 22.
Lesson 31, question 17, I think.
31, number 17.
Yeah, I think.
Okay.
Lesson 32, 7, 9, and 8. Okay. The same question.
32, number 7, 9, and 8.
For question, for lesson 29 and question 5.
29, 5. Okay, let's go with these to get us started. All right, let's see. Let's look at 29 to begin with. Okay. 29, numbers 5 and 22. All right, 29, number 5. Okay, excuse me. This says for every 130 squirrels in the forest, there were 156,000 good places to hide. If there was a total of 3,250 squirrels in the forest, how many good places to hide were there? Okay, so they've started off and told us a relationship for every 130 squirrels, there are 1,560 good hiding places. So 130 squirrels is equal to 156,000 hiding places. You know, just how we would put, 1 foot over 12 inches, the idea that those two things are the same, right? Okay, so 1 foot is the same as 12 inches, just like they've told us 130 squirrels, we have 156,000 hiding places. So that's how we're going to make that a fraction there. Okay, so then they ask after that, if there was a total of 3,250 squirrels, so now we're wanting to find out if there's 3,250. You think about the fact this is squirrels, this is my hiding places. All right, then how many good hiding places were there? Okay, so I'm going to solve for X here. I'm going to solve for the number of good hiding places. So I've just set up these two ratios where the top number is the squirrels, the bottom number is the number of hiding places. Okay, so everything's in the same spot, right? So now I'm going to cross multiply and get this 130x equals 156,000 times 3,250. And that's going to give me some number that I'm not going to bother calculating out right now. This will give me some number, right? If you multiply this times this right here is going to be this 156,000 times 3,250. All right. So now I'm going to take and divide both sides by 130 to isolate my x. Good. Follow where I am. So when I divide both sides, I'm going to get that the number of hiding places, or x, equals 3,900,000. So for this one, it's just a matter of setting up that fraction, those ratios in the beginning. There we go. You're good. Okay, good on that. All right, so that was number 5. Now we're going to stay in chapter 29 and we're going to go over and look at number 22. Okay. Okay. So here we have two fractions that we need to add together. Okay, so we have 3m over m squared plus 3m plus 2 minus 5m over m plus 1. Okay, so remember that fact that I need to get a common denominator, right? Okay, and most likely, if I factor this right here, I'm going to find that that right there is one of the factors. Okay, so if I go to factor this right here, my m squared is going to come down with the m and the m. Okay, and then I'm looking at the fact that I need to do something with the factors of 2 that I can combine to also get 3. So I'm going to go with 2 times 1, right? Okay, and if they're both positive, that gives me the 2m and the 1m add together to get the 3m, and the 2 times 1 positive gives me that. Okay, so I see that this denominator right here already has this in it, right? So both of them already have that in them, but this one over here does not have this term in it. Good. Okay, so in order to make them the same, this over here has to be multiplied by this m plus 2. Do we get that this denominator right here is m plus 2 times m plus 1? Well, this denominator is just m plus 1, so I'm going to now multiply this by m plus 2. And if I multiply the denominator by that, I'm also going to multiply the numerator. Good? Okay. All right. So this equation over here, I don't need this fraction. I don't need to do anything to it. It's going to stay the same. But this one right here, I'm going to multiply. And I've got this 5m is going to be multiplied by m. And then the 5m is also going to be multiplied by the 2. Okay, so I'm going to keep this 3m up top, right? Okay, and now I've got the 5m times m is going to be 5m squared, and it's going to be negative, okay? And then I'm going to also again have this negative 5m that I'm going to multiply by the 2, so I'm going to get negative 10m. Okay, so that's what I have on the top. And then my denominator is m plus 1 times m plus 2. All right, I can combine those, these right here. I've got this 3m and the negative 10m. All right, so it's going to give me negative 7m. So I'm going to wind up with this negative 5m squared minus 7m over m plus 1 times m plus 2. Good. Questions that you guys have with that? Is there a place where I did something and you're like, I don't get, what did you do there? Everybody's okay? I'm going to move on from there. Okay, so that was 29. Let's go on to 31. We're going to look at number 6 in lesson 31. Okay. So lesson 6, number 31, this is going to be probably similar to the other one. It says 40 grams of potassium combined with 1,400 grams of other elements to form the compound. So we've got this idea of 40 potassium goes with 1,400 of the other. If 4,320 of the other were needed, how many grams of potassium were required? Okay, so we were told that we get 40 potassium with 1,400 other. So these two go together, 40 over the 1,400. Okay, this is potassium and this is other. All right, and then the rest of the problem says if 4,320 grams of the compound were needed, how many grams of potassium were required? Okay, so here I've got down here this 4,320. Okay, excuse me. This right here, where I threw myself off where I said this was other. This isn't other, this is the compound. So I had the idea that I put 40 grams of potassium with some other stuff to get 1,400 of the compound, right? So 40, when I have 1,400 of the compound, I have 40 grams of potassium. Good. So now they're saying if I have 4,320 grams of the compound, how much potassium do I have? All right, so it's just like the other one. We're going to now cross multiply 1,400 times P. So this 1,400 P is going to equal 40 times 4,320. Yes? I'm going to then take and I'm going to divide both sides by 1,400. Okay. And we will get that P equals 120 grams. Okay, so P equals 120. So again, just developing those relationships when they tell me I need 40 grams of potassium to produce 1,400 grams of the compound. So I'm able to set those up as a ratio. All right, any questions on this? Okay. That was 31, number 6. We're going to move on to lesson 32, and we'll look at this 7, 8, and 9. Okay, 7, 8, 9. Yeah, and these are all basically the same type of thing here, right? Okay. So we've got radicals that we're adding together. Okay, and so think about the fact we've got 2 things we need to do. 1, we need to get rid of the radical in the denominator, and then 2, we're going to wind up needing to have a common denominator. All right, so I'm going to start off here, number 7. My problem is the square root of 2/3 plus the square root of 3/2. All right, so remember that I get rid of the square root in the denominator by multiplying top and bottom both by that same square root that's in the denominator. So over here, I'm going to multiply this by √3 over √3. And this one over here, I'm going to multiply by √2 over √2. All right, the 3 times the 2 is going to be the square root of 6. But when I get the square root of 3 times the square root of 3, I think about the fact that's the square root of 9, right? And the square root of 9 is 3. So now I have a denominator that's just the 3. Up here, I get the square root of 6 in the top. The 3 times the 2 is the square root of 6. But the 2 times 2 is 4, and the square root of 4 is 2. All right, and so now I just need to get the common denominator. So now I'm going to multiply this fraction over here by 2 over 2 to get the common denominator of 6. I'll multiply this one by 3 over 3, and here I'll get 2 √6 over 6 plus 3 √6 over 6. Okay, and so now I can combine those two things together. And I think about the fact that these are the same type of things. The number that's under the radical sign is the same. Therefore, I can indeed add these together so that I'm going to get 5 √6 over 6. Yes. I thought someone said question.
I was saying question. I was saying question.
She's so calm. Okay. All right. Good. Follow that. That I can combine those two things on the top because the number that's under the radical sign is the same. Okay, so you have 2 steps that you need to go through in this problem. You need to first get rid of the radical in the denominator, and then you need to get the common denominator after you've gotten rid of the radical. Good. Okay. And the next problem after that, you've got a very similar sort of thing going on in number 8. Okay, number 8 is 2. And then you have the square root of 5/7. And that is minus 3 and the square root of 7/5. Okay, so again, I'm going to need to get rid of my square root on the bottom, and then I'm going to need to find a common denominator. Okay, so let's go with this right here. I've got this 2 square root of 5 over the square root of 7, and I'm going to multiply both top and bottom by the square root of 7, okay, so that I wind up with 2 √35 over just 7. Good. And then over here, I have this 3 √7 over √5, multiplying it by √5 over √5. Remember, I'm subtracting, so I wind up here with 3 √35 over 5. Okay. And now I need to just multiply it by that common denominator. So up here, I'm going to need to multiply this one by 5 over 5. And I'm going to multiply this by 7 over 7. So then I'll wind up with here 10 √35 over 35. I've worked myself into the corner of my board, right? Okay, so now that I've got 7 times the 3 is going to be 21 √35 over 35. So let's pull this back out here. Okay, so I have 10 square root of 35 over 35 minus 21 square root of 35 over 35. Are we good with how I've arrived there? Any questions on how I got myself to that point? Okay, and now these are the same thing because this is 10 √35. This is 21 √35. So I can combine those two and I've got the same denominator. So the 10 and the negative 21 is going to give me negative 11 √35 over 35. Okay. And then number 9 is basically the same thing. So I'm not going to take the time to do that one because you're just going to do the same process. All right, any questions on that process right there? Ben, you good? Okay, all right. Okay, so we're moving from there and we're going to go on to lesson 33. All right, well, going on to 33, we're on the first number 1. Okay. Okay, so this says 4/17 of the hedonists were also Sibarites. If 104 were Sibarites, how many were hedonists? So again, this is very similar to what we've already done. They said 4/17 were hedonists. Of the hedonists were also Siberians. So I'm going to have that I have 4/17 of the hedonists are also Siberians. If 104 are Sibarites, so we've got 4 out of the 17 are Sibarites. So now they wind up saying if 104 Sibarites, so now I'm going to have the 104 up here. Here's my 4/17. And then I'm solving for this down here, which is going to be the hedonist that I'm solving for. Okay, they told us that this was 4/17 are Sibarites, and then they say there's 104 Sibarites. Just making sure that you get the same item, and always put the same thing in both equations. So you put the same thing in the top for both of them, and then just cross multiply. So I wind up with 4H equals 17 times 104, right? And then I divide both sides by 4. And in the end, I'm going to get that there are 442 hedonists. So H equals 442. Good. All right, we're moving from there on to number 17. All right, let's see. Number 17, we have radicals, and we're adding them and subtracting them, right? Okay. All right. 318, 250, and 98. Okay. So you've got 3 root 18 plus 2 root 50 minus 98. And that's going to be the square root of. Okay, so we need to see, where do we have square roots in here that we can factor out, okay? So thinking about the fact that the 18 is 2 times 9, right? And what's the square root of 9? 3, right? Because 9 is 3 times 3. So I'm going to be able to pull a 3 out of there. This 9 is going to come out as a 3, which I'll multiply by that 3, and I'm left with the 2. So here I wind up with 9 square root of 2. Okay. Over here, we know with the 50 that 50 is 2 times 25, right? And that 25 is 5 times 5. So this 25 gets to come out of here as a 5, which I'll multiply by the 2. And I'm left with a 2 underneath there. So 5 times 2 is 10. And I'm left with this 2. Okay. 98, we don't recognize right off the top of your head as to what the square root is with 98, do you? Okay. But if I take 49 and I multiply it by 2, is 98. And 49 is 7 times 7, right? So this 98 is 2 times 7 times 7. So the 7 is going to wind up coming out here. And the 2 is going to stay underneath there. Okay, so I'm going to get that. So here I wind up, this is going to be minus 7, the square root of 2. Okay, convenient, they all wound up being something the square root of 2, so I can go ahead and combine those together. So I've got a positive 9, a positive 10, and a negative 7. So that's going to give me 12, the square root of 2. Should this be negative? This is just an equal sign is what I drew. Yeah, yeah. Okay. So just with those, when you've got those, just take and reduce your radical down as far as you can. Make sure you get out any square roots that are in there. And then as long as the number that's under the radical is the same, then you can combine them. If the number under the radical is different, you cannot. Okay? All right, let me see what I want from you guys as far as homework goes. How about if y'all give me, y'all did 33 this week, yes? You guys have 33 that you could give me? This is you. Yes. Yeah. Thank you. Definitions and things? Okay. All right. Okay, let's look at what we're doing this week real quick. Okay, so this week we are going over lessons 35, 36, 38, and 39. We're skipping 37. 35, 36, 38. 39 too. I'm grabbing another one here. Yeah. This one. It's 39. Okay. There's 39. Okay, I'm not finding 39. I know y'all hate to miss out on something, right? Okay, so let's look at this. Okay, so lesson 39 starts off with fractional exponents. Let's see what comes up. Okay, if I've got the square root of 3, I can write it as a fraction as 3 to the 1/2. Okay, so when I look at this 3 to the 1/2, 3 to the 1/2 means the square root of 3. That's how we're going to write that, okay? This is lesson 35. If I've got the square root of 36, that's the same as 36 to the 1/2, okay? If I wrote 2 to the 1/4, that means the 4th root of 2, okay? So whatever is in the denominator, is the root that I'm taking. 3 to the 1/3 means that I want the third root of 3. So that winds up being fairly straightforward. Okay, so the fractional exponents are going to be handled just like regular exponents as far as combining them. So if I have x to the 1/4 times x to the 2/4, okay, think about that. If I had x to the 1 times x to the 2, I would wind up adding those, right? And say that I have x cubed. When I multiply those two, they come to x cubed. Well, right here, I'm going to do the same thing. So x to the 1/4 times x to the 2/4 is going to equal x to the 3/4. All right. Also, remember, if I had, x squared and I squared x squared, that's the same as x to the 4th. So when I take a power and I raise it to another power, I multiply it. We're going to do the same things with the fractional exponents. So that if I have x to the 1/2 and I take that and I raise it to the 2/3, I'm going to multiply the 2/3 times the 1/2, and I'm going to get x to the 2/6. Okay. So nothing terribly new is going on there. We're just doing it with fractions. So remember, with your fraction, whatever the denominator is, that's the root that you're taking. If you've got your fractional exponents, if they're being multiplied, add them just like you would before. If they're being raised to another power, multiply them just like you would before. Okay. Moving on from there, let's look at the idea if I've got a negative fractional exponent. So if I have 4 to the negative 1/2, remember if I had 4 to the negative 2, that meant that, right? If I had 4 to the negative 2, I would wind up then still having 4 squared, but it means for me to take the reciprocal of that. So now this right here is going to be the same thing. I'm going to have the reciprocal of 4 to the 1/2, which is going to be 1 over the square root of 4. Okay, and think about the fact that the square root of 4 is 2. So this is going to equal 1/2. So 4 to the negative 1/2, because it's of the negative sign in the exponent, that just means I'm going to write it as the reciprocal. Okay. Then because of the fraction in the exponent, I'm going to write it as a square root. Okay. All right. So if I had 36 to the negative 1/4, I want you to think about how would you handle that? You have 36 to the negative 1/4. Okay, so I want you to try and answer that one. So you'll work that out. We're doing 36 to the negative 1/4. So you're going to think about two things. You're going to think about what does it mean to have the negative exponent, and then you're going to think about what does it mean to have the fractional exponent. Okay. So as you've done that, what does it do? What happens when I have a negative exponent? The reciprocal, right? I'm going to put it down as the reciprocal. So if I do that, this is going to equal 1 over 36 to the 1/4. Okay. Now, what does that 1/4 exponent mean? Remember, what would it mean up here when I had the 1/2 exponent? Remember that meant square root, right? So now the 1/4 exponent is going to mean a 4th root. Okay. So if I have 14 to the negative 1/3, because of the negative, it's going to become the reciprocal, right? So can you take this right here, this 14 to the 1/3, and write it as the reciprocal? So I've got my 14 to the 1/3 written as the reciprocal, right? Now, what kind of root of this am I going to take?
Wasn't it just 4? 1, 4? Just 1, 4.
Should this right here be 1/4?
Thought it would be.
I don't know if the third root, the cubed root of 14 is 4. I wouldn't think that it was necessarily. So you had the idea 14. I still have to have my 14.
36 by 36 by 4.
This is
Are you up on this problem here?
Oh, okay.
Okay, yeah, I didn't actually go over and answer this problem right here. I didn't go any further than that. Yes, thank you. I was trying to figure out how I got to 1/4 there. Okay, yes, so we're down here on this problem right here. Okay, just even writing it out. I wasn't even worrying about trying to figure out what is the 4th root of 36. I don't know.
No. Oh, it's not. That's good.
It's not going to be 2. I'm not going to deal with that at the moment. Let's stay right here for just a second. So here, because I've got this 3 down here, this is going to be root 3 of 14 over 1. Yeah, and it's not going to be 4 either, because 4 to the 4th is too big also. So I don't know what the 4th root of 36 is. Can I figure that out real quick? But again, so yeah, even with that, we're fine leaving it right here. So yes, as you guys are working your problems, they're largely fine leaving it right here. They're not looking for you to actually use your calculator and figure out the decimal number that's right here. Because the point of this is, do you understand what this right here means? And I do understand that 36 to the negative 1/4 is 1 over the 4th root of 36. This is where they're looking for you to leave that answer. Okay. I mean, if it came out, if your problem was actually 36 to the negative 1/2, then you're looking at the idea that this is the square root of 36. And at that point, yeah, go on with it, because that's a root that you're going to easily know. The other thing's going to be some ugly decimal point. Okay. All right. One more level that we're going to take this to now. All right, let's go. If I've got negative 27 to the negative 1/3. Okay, so I've got this negative number out there that I need to deal with, this negative sign. Okay, this is not going to be that bad. So thinking about the fact, because this is negative, I know that I'm going to have a reciprocal situation, right? Okay, so now I'm going to have this 27 and the 1/3. I know that's going to tell me that this is a cubed root, right? So we're good with all that. If this was positive, I would know this is the cubed root of 27 over, the 1 over the cubed root of 27. Okay, now with that negative sign that's going there, it's fairly simple. You can put the negative sign, just out here, and we can wind up thinking of it as, negative 1 over the cubed root of 27. You can wind up thinking of it as 1 over negative cubed root of 27. It really doesn't matter where you consider that negative sign to go. It's just the general idea that that's going to be negative overall. Okay, so the negative is going to come along with it. So this is going to actually equal negative 1/3. Good. So you're just going to have that negative sign. So if I have negative 16 to the negative 1/2. Okay, I'm just going to put my negative sign out there, right? because of this negative right here, it's the reciprocal. Down in the bottom is the square root of 16. Okay, so this is going to be negative 1/4. So don't let that negative sign, throw you there. Just add the negative sign. Good. Okay. That is what's happening in lesson 35. Okay. Lesson 36. The title here is Contrived Problems. All right. And contrived problems, we're going to have, say, if you've got something like AB over CD plus 4x over A plus 2B over AC. And you're looking at this and going, when am I ever going to use this in my life? When am I ever going to be faced with something like this? You're never going to be faced with something like this. You're not going to do this in your real life. Okay. The purpose of the problem is for you to be able to work through the problem solving skills of what are the steps that I have to go through? Do I understand how common denominators work? So you're really, it's something that's contrived. It's not something you're ever going to do. It's just continuing to work those skills. So don't be frustrated with that as you see that, because yeah, it really is something they're just making up to give you the opportunity to practice the skill of common denominators and just moving around a lot of things and looking at, why are we using all these letters instead of using the numbers? When I use the letters, I can watch where things move throughout the problem. Okay, the C stays a C all the way out through the problem. Well, if I had a 3 here and a 2 here instead, over here that would become a 6. And I'm no longer seeing those elements of the problem move throughout the problem. So that's where we'll use those letters. So you can watch how things combine and you can kind of see what's going on there. Okay, so know that that's what's happening there. The purpose of it is so that we can practice factoring and canceling and common denominators and all of that. Okay, so remember, if we've got 2/3 times 4/6. Okay, we remember that we do the top times the top gives us 8, and the bottom times the bottom gives us 18. So we remember that when we multiply fractions, we multiply top times top, bottom times bottom. We don't need a common denominator, right? We're just going to deal with that all the way across. Okay, so when I then see A over X times 3 over X plus Y, it's the same thing, top times top, bottom times bottom. So I'm going to do the A times the 3 gives me 3A, and then here the X times the X times the Y. So I'll get X squared plus XY. I'm just doing the same thing. Good. Okay, so now we'll bump that up. The basic idea. And let's look if we have X squared plus X minus 12. We also have X squared plus X minus 12. My denominator is going to be X squared minus X minus 20. Okay. I'm going to multiply this by X squared plus 2X minus 35. And the denominator here is going to be X squared plus 9X plus 14. Okay. All right. Think about the fact that if you had, I'm not going to do this well, 27/8 times 32/18. Okay. Think about the fact that I would start canceling things. I would see the fact that these are both a factor of 9, right? And so I would divide this by 9 and get, you know, not 3, I would get 2. I would divide this by 9 and I would get 3. I can see that these right here, you know, are both divisible by 8. 8 goes into this right here. 8 goes into here 4 times. So now I just have the 3 times 4 over the 1 times 2. So I've just got, good. I'm not going to actually multiply all that stuff out. I'm going to see what are the common factors within there. So I can think about the fact that I looked at that this was 3 times 9. This is 8 times 4. This is 1 times 8. And this is 9 times 2, right? And so then I start canceling out those things that are the same. So I'm just left here with the 3 and the 4 and the 1 and the 2. Good with how we would do that, right? Okay, we're going to do the same thing here. It'll look a little messier, but you're really just doing the same thing. So just think about that. So here I factored each of these items. So what I'm going to do here is I'm going to factor this. And I'm going to factor this. I'm going to factor this. And I'm going to factor this. And I'm going to see where are my common factors. And then that way, whatever factors are common top to bottom, I can cancel those out and I don't have to deal with them. Because looking at the problem like it is right now, it looks like a mess. Okay, so let's think about how we can factor this. Of course, I've got my x and my x. I have the 12. What are the factors of 12 that are going to come to 1? It's going to be 3 and 4. So if I've got a 4 and a 3, my x needs to be positive. So this greater number needs to be positive. The lesser number needs to be negative. All right, so down here, I have my x and my x. I think about the factors of 20 that are going to give me 1, and that's going to be 5 and 4. 5 and 4 I can combine to get a 1. Okay, this right here needs to be negative. So that means that the 5 is going to have to be negative, so it's bigger, and the 4 will be positive. Okay. All right, we're coming over here. I've got my x and my x, 35, and I need to think about the factors of 35 that can give me 2. So that's going to be 5 and 7. Okay, the 2 needs to be positive. So that means that the 7, the larger number, needs to be positive, and the smaller number is going to be negative. Okay, and then here, right here, I've got 14. Okay, so I'm looking at a 7 and a 2. Okay, and here I've got the 9 is positive. I'm going to wind up just adding both these 7 and 2. I add together to get the 9. So these are both going to be positive here. Okay, so now I can look and see where do I have factors that are the same that I can cancel out. All right, so here I have an x plus 4 on the top and on the bottom, so I can just cancel those out. Here I have an x plus 7 on the top and the bottom, so I can cancel those out. And here I have this x minus 5 on top and bottom, so I can cancel those out. So all that I'm left with is x minus 3 on the top and x plus 2 on the bottom. Okay. So think about the steps that we went through to solve that, okay? And the fact that we took our problems, each of our equations, and we just factored them, and then we canceled out the common factors, and we just dealt with what was left at the end. And in this situation, we just had 1 on top and 1 on the bottom. That's all we had to deal with, okay? If looking at a different type of problem, if you've got a division problem, okay? So you've got 2 of these, and instead my symbol is divide. How is a division problem going to work different than a multiplication problem? What do I have to do to divide by that fraction? When you divide by a fraction, what do? Invert and multiply, right? So if I'm looking at this right here, and if I had a division symbol in here instead, I would have had to have inverted that second one, right? And then you would multiply. Follow? Okay. So that's how that's going to look. let's do something else here. Hold on a second, sorry. If I've got x squared plus x minus 6 over x cubed minus 2x squared minus 35x. So I have x squared plus x minus 6, numerator. My denominator is x cubed minus 2x squared minus 35x. Okay. And then this is going to be divided by x plus 3 over x squared minus 7x. Okay, so as we go to do this, we've got a couple of issues. One, it's a division problem, so I'm going to need to flip that second fraction, right? And I'm going to multiply. So I'm going to bring this down here. I'm going to change my sign to multiplication, and I'm going to wind up flipping over there. All right, so let's go ahead and deal with this first one right here. Okay, think about the fact that I'm going to factor this right here. I'm factoring the top one. This one right here is this top one right here. So I have the x and the x, right? Okay. My factors here are going to be 3 and 2. All right. I've got to get the x. I've got to get just the 1. So I'm going to have to take the 3 minus the 2, right? The 3 is going to have to be positive because I need my middle number to be positive. So it's going to be positive 3. And then this is going to be negative 2. All right, as I go to factor this bottom one, what's the problem that I run into as I go to do this one? Yeah, we've got that x cubed, right? We don't have an x squared, we have an x cubed, and notice this has an x squared, and you notice that this down here has an x. So everything has one more x in it than I need it to have. So I'm just going to factor out an x. So when I come down here, just factor an x out of everything. And when I factor that x out, okay, this now becomes x squared minus 2x minus 35, right? Now we feel much better about that. Okay, so I'm dealing now with the factors of 35 that I'm going to be able to combine and get the 2. So thinking about 5 and 7, okay? So I've got my x and my x and my 5 and my 7. Okay, and this is negative, so I'm going to have opposite signs. I need the 2 to be negative, which means that the 7 has to be negative. The larger number needs to be negative. Okay, and the 5 is going to be positive. Okay, so now I'm going to come over here. I need to flip this. Okay, so this is what I'm going to have in the top. Okay, notice here in the top I have x squared minus 7x. All right. Notice all these other things just have an x and plus or minus 1 digit. So I want to get these extra x's out of here. So I'm going to factor out the x and just wind up with x minus 7, x times x minus 7. That looks a whole lot like all of my other factors, doesn't it? That x minus 7. Okay. And then this right here, because I'm inverting, that's now going to go down on the bottom, x plus 3. All right, and now I'm able to just go through and cancel out like items. There's the x plus 3 twice. Here's the x minus 7 twice. Notice here I factored out an x. And over here I factored out an x. Y'all should try crossing through an x sometime. No matter which way you do it, it's just as weird. If you're trying to cancel an x and you just draw it, that just comes out weird. So anyhow, we cancel those 2 x's. Okay, and so now up top, all I'm left with is x minus 2, and down on the bottom, I'm left with x plus 5. Okay, they look scary, but they're really not bad. So just factor them, and then cancel out the like factors. Good. Okay, in true Saxon fashion, we'll switch to something just totally different again. Okay, all right, I'm skipping over lesson 37. I'm going over to lesson 38. And we are going to look at powers of sums. Okay, so here, if I've got, a squared, that equals a times a. If I have a cubed, that's a times a times a, right? We're happy with that. If I have a cubed times a squared, that is a to the fifth. I add those, all right? And then if I have a cubed and I square that, I get a to the sixth because I'm going to multiply those. Nothing new there. Okay, so now if I have a squared, b cubed, c squared, and I tell you to square that, okay? That's the same as a squared, b cubed, c squared times a squared, b cubed, c squared, right? So if I multiply those, a squared times a squared is going to give me a to the fourth, b cubed times b cubed. I'm going to add those two together and get b to the sixth. And the c squared is going to give me c to the fourth. Yes? Okay. Conversely, I could take 2 times 2 is 4, and I get a to the fourth. 3 times 2 is 6, so I get b to the sixth. And 2 times 2 is 4, so I get c to the fourth. You see how that's the same thing. I can take them side by side and multiply them by that, multiply it by itself, or I can just take and 2 times 2, 3 times 2, 2 times 2. Good. Okay. So remember, that's just called the power theorem, and that fact that when we raise something to another power, all I'm doing is taking each of those and multiplying it by the exponent is all that I'm going to wind up doing. Let's look at these two different things. If I've got 2x squared plus 3y, squaring the whole thing, versus 2x squared times 3y squared. Let's see how those two things come out. Okay, notice this is a sum. All right, so here I'm taking 2x squared plus 3y and I'm multiplying it by 2x squared plus 3y. Okay, so here I'm going to take that 2x squared, I'm going to multiply it by this 2x squared, and I'm going to get, 4x to the fourth. I'm going to take this 2x squared, multiply it by the 3y, and I'm going to get 6x squared y. Okay, now I'm going to take this 3y, multiply it by that 2x squared. You get how I'm going across. Okay, so I'm going to get 6x squared y. And then I'm going to multiply this right here and get 9y squared. So when I take those two and multiply them, I'm getting 4x to the fourth plus 12x squared y squared plus 9y squared. Okay, so I'm getting this whole trinomial down here. Conversely, if I take this right here and I have 2x squared 3y and I multiply it by 2x squared 3y, Okay, I'm going to wind up doing the 2 times the 2 is 4. The x squared times the x squared is going to give me x to the 4th. Then the 3 times the 3 is 9. And the y times the y is y squared. Okay, so to get a totally different answer. So that's one thing for you guys to really watch against. Are you having 2 items that are being added together, squared? Or are you having 2 items that are being multiplied by each other, squared? So you see the definitive difference as far as what that answer is going to be. This right here has me squaring each item in there. Okay, for this right here, I have to take this binomial, multiply it by the other binomial, and produce a trinomial. So watch for that difference, okay? That's something that'll kind of catch you up. Okay. All right. If you had, you could also have something cubed. If you have one that's cubed, you wind up, say if this right here was cubed, you wind up doing this right here, and then you come down here again with another 2x squared plus 3y, and then you would need to multiply that out again. Okay, multiply the 2x squared by each of these, multiply the 3y by each of these, add them together, and you would then get a, 4 different terms. Yeah. Okay, let's see, one other thing that we have to show you here real quick with this. Okay, and think about if this was cubed, you would be doing, 2 cubed x squared times 3 is going to give you 6. You would cube your 3, and you would do y times the 3 is going to give you 3. Okay. All right. Solve by factoring. Okay. This is still in lesson 38. Okay. Think about x times what equals 0. What do I have to multiply at 8 times in order to get 0? Right. So anything times 0 gives me 0. All right. So that's going to be our foundational principle is 8 times 0 equals 0. If I want to get 0, I have to multiply something by 0. This is going to be the 0 factor theorem. And we have this idea that if I have to say P and Q, and they're real numbers, and if P times Q equals 0, then either P has to be 0 or Q has to be 0. If I take 2 numbers and multiply them together and get 0, one of those 2 numbers is going to have to be equal to 0. Okay, so if I've got negative x plus x squared equals 6, all right, and you're going to be told to solve by factoring. Okay, and remember that factoring means I need to find the 2 numbers that multiply together to get something else, right? The factors of 27 are 3 and 9, find those factors. Or where we've taken a trinomial and we found what are the 2 binomials that I can multiply together to get that trinomial. Okay, so here we're told to solve this by factoring. So what I'm going to do is I'm going to take this whole thing and I'm going to set it equal to 0. So my 6 is going to come back over. Okay, so I'm going to subtract 6 from both sides. I'm also going to rewrite this. So my x squared is at the beginning. So I wind up with x squared minus x minus 6 equals 0. Okay, so you see what I did? I wound up moving the 6 over to this side and set the whole thing equal to 0. All right, now I'm going to factor this. Got my x and my x. I'm thinking about the 6 with the 3 and the 2. The 3 and the 2, and x has this, the 3 has to be negative and the 2 has to be positive. Okay, so I still have this, I factored it, and I still have to equal to 0. Okay, and remember that we said, in order for this to equal 0, either this first factor has to be, the value of the first factor has to be 0, or the value of the second factor has to be 0, right? So what I'm going to do is I need to find what's the value of x that would make this first term 0. And what's the value of x that would make this second term 0. You guys following me? Okay. All right. So what I do there in order to figure that out is here I find out x plus 2 equals 0. I'm solving for what value of x will make this equal to 0. Subtract the 2 from both sides. And here I get that x equals negative 2. Over here, I take this x minus 3 equals 0. Add the 3 to both sides. Okay. And I get that x equals 3. So what I found out is there's 2 values for x that will solve this problem. So x equals negative 2 or x equals 3. So either negative 2 or 3 will solve this problem. Okay, because think about it, when I plug in x equals negative 2, this is going to equal 0. All right, and then I would have this over here where I, I would have this right here is going to equal 0, and 0 times this right here is going to equal 0. If I put a 3 in here, then this right here would be 0. And then, this right here, the 3 plus 2 is 5. 5 times 0 is 0. Okay, so that's that found here. So I could plug these numbers in. If I plug negative 2 in, it'll work. If I plug positive 3 in, it'll work. All right, so when we're told to solve by factoring, I set the whole thing equal to 0. I factor it, and then the thing you cannot forget is I have to solve this for 0 and solve that for 0. Okay, if you have negative 35x equals negative 2x squared minus x cubed, okay? And we're told, all right, solve this by factoring. I need to get everything on one side and set the whole thing equal to 0. Put everything on one side and put it in the right order so the exponents are descending. All right, so let's move these things over to this side so that I get this positive x cubed. I'm going to get a positive 2x squared, and I still have this negative 35x equals 0. All right, if you were going to factor this, what's the first problem that you run into? Or what is the problem you run into? Too many x's, right? Everything has one more x in it than I need for it to have. So I'm just going to factor out an x. So factor out an x, and then you're left with x squared plus 2x minus 35 equals 0. Now, can you factor that trinomial in the center? Yeah, it looks much better. Keep this x down here. Okay. Remember to still set it equal to 0. We're going to have the x and the x, and my 35, we're going to use 7 and 5, right? 7 and 5. My middle term is positive, so that means this one needs to be positive, and that needs to be negative. Okay, now we're going to have those 3 different factors. Notice here, I'm multiplying this by this by this. Okay, so in order to multiply things and get it to equal, one of those items has to be 0, right? So I need to set all of these equal to 0. Well, this right here is just x. So here I'm going to have x equals 0. Here, x minus 5 equals 0. Here, x plus 7 equals 0. This one's already solved for x. Here, move the 5, so x equals 5. Here, move the 7, so x equals negative 7. So my answer is x equals 0, 5, or negative 7. You could actually write it as negative 7, 0, 5, just to put it all in numerical order. All right, so I've got three different values for x. Okay. Questions on what did we do there? Y'all are okay? All right. Let me show you some stuff from lesson 39 real quick. All right, lesson 39, we've got the difference of 2 squares. All right. So look at this. If I've got negative 2x minus 3y, all right, and over here I have negative 2x plus 3y. Okay, this is an expression. This is an expression. Okay, this right here is a term. This right here is a term. This is a term. This is a term, right? The only thing different between these is just this sign right here. Okay, otherwise than that, these are the same, but we've changed that second sign. All right, so what we would wind up saying with this is these are conjugates. Okay, these are called conjugates. Conjugates are going to be two expressions with the same terms, but a different second sign. So everything is the same in the conjugates, except for the second sign is different. All right, so if I've got 4x plus 3y, the conjugate is going to be 4x minus 3y, right? All right, so let's see what happens when I take my conjugates and I multiply my conjugates. I get 4x plus 3y multiplied by 4x minus 3y, okay? 3y times 3y, okay, is going to give us this negative 9y squared. The negative 3y times the 4x is going to give us negative 12xy. When I do this, 4x times the 3y is going to give us positive 12xy. And then I multiply my two first terms, and I'm going to get 16x squared. When I add these together, I get 16x squared minus 9y squared. All right. When I look at these two things right here, notice 16 is 4 squared, right? X squared is x squared. 9 is 3 squared. Y squared is y squared. What I have here is what we call the difference of two squares. All right, the difference of two squares. So this is a square. This item 16x to the fourth, x squared is the square of 4x. 9y squared is the square of 3y, right? And I've subtracted them. So what we found right there is if you have, so we're going to kind of work backwards. What we've learned here is if you have an expression and your expression is made up of two squares that are being subtracted, if you have the difference of two squares, the answer is going to be these two conjugates. So the answer, if you notice this right here, these terms right here are the square root of this term, yes? These terms right here are the square of this term, and they're conjugates. So if I have this right here and I'm told to factor this right here, this is the difference of two squares. So I have the 4x, I have the 3y, and they're going to be conjugates. So I have the positive and negative. So we started here to get there to be able to show you when you start with this, when you're given the difference of two squares and you're told to factor it, you take the square root of first term, square root of the second term, and then put the opposite signs. Okay, not bad. Sounds a little crazy when you do it, okay, that makes sense. Good. All right, that is all that I have for you guys today. And now you're off to get focused and all that other good stuff.